How do you visualize Chicago? If you live here, the city might just be your home. If you go to school here, Chicago might just be Northwestern. My name is Anastasia Montgomery, and my visualization of Chicago is a little bit less concrete. I see Chicago as a combination of these invisible pollutants, which impact human health and the environment. Pollution attributes to over 100,000 deaths in the US every single year, and this burden is not equally distributed. Elderly and children are more likely to be impacted by this pollution, and lower income and minorities are more likely to live in areas with high pollution. So when we're looking at pollution, we want to understand where and why it is forming. The gold standard of air quality monitoring comes from the EPA. The EPA has federal monitors across the entire United States, but these monitors are only available across certain points in our country, and these points are only spatially representative of a certain area. So when we want to actually find where these pollutant hotspots are, we need to integrate other data sets. As a result, I use satellite data. Now, satellites orbit the Earth every single day, taking a snapshot of air quality once a day. These are providing us the geospatial resolution of the data that we want to see, but they're losing the temporal resolution of what's actually happening within our system. So in order to get over this temporal and spatial gap, I use a chemistry climate model. Now, chemistry climate models take emissions and physics and then simulate what's happening across all of time and space in order to represent what's happening in our environment. And while these models are really good, they're still only an estimate of what's actually happening. So I combine the sensors, satellites, and model data in order to get closer to the truth of air quality in Chicago. So when we combine these data sets, we actually can begin to actually see the spatial heterogeneity of the pollutants within our city. Here, I have a map of nitrogen dioxide. Nitrogen dioxide in cities is a byproduct of combustion, which means that it's formed when we drive our cars or when we make energy. From this map of nitrogen dioxide, we can see this elevated pollution over our highways and into the loop. We can also look at pollution on a really bad air quality day. From this map, we can see that the pollution, given the worst environmental conditions, the pollution pretty much stays in the same place. And looking at this difference, we can see that the entire city is experiencing higher levels of pollution, but also these corridors are still at higher levels. And looking at this mathematically, we have to pull out the fact that these high pollutant areas are going to be consistently high pollutant. So then that means that the people who are actually living in these areas are consistently experiencing higher levels of pollution as compared to the rest of the Chicago population. So when we actually look at this map of nitrogen dioxide, it looks like we're looking at the emissions of cars, but we have a model, so we can actually start to look at what the emissions look like and then what the nitrogen dioxide looks like on an hour-by-hour basis. So in the center panel, I have nitrogen dioxide emissions, which are cycling up and down as the day progresses. And then on the far left, I have a chaotic mess, because this is the model taking these orderly emissions and applying the chemistry and the weather in order to simulate what's actually happening in our environment, which is a really chaotic system. So when we're looking at pollution and its impacts, it's not enough just to look at where the emissions are. We also need to consider the chemistry, the transport, and the climatology of the area. Ironically, in order to figure out what's happening at a fine scale within our city, we need to actually start looking at the climatology. Let me define climate for you. Climate is weather averaged over time. We've simulated a month here, and this picture is not going to hold forever. I've shown you the fact that the pollution is elevated across these highways and into the loop, but these emissions are actually the distinct anthropogenic footprint of our activity in our atmosphere. When we're looking at these emissions, we're also looking at what is changing, the bigger picture. Moving forward, we can use these high-resolution air quality maps, but it's not enough to do nothing. We need to use these maps and move forward with smarter and more informed policy decisions. Thank you.